In this video, I'm going to work out this limit. So as always, the first thing I should do is I should check my type, and when I evaluate the numerator at -1, I get 0, and when I evaluate the denominator at -1, I get 0. So this is an indeterminate form, which means I must change the function somehow so that I can get it in a form where I can evaluate the limit. So the natural thing I want to do is factor. And note that I just evaluated at -1, and when I plugged in -1 to the numerator, I got 0. So that tells me, of course, that x minus -1, or x plus 1, is a factor of x cubed plus 2x squared plus 2x plus 1. So I'm going to go ahead and use long division so that I can factor that, because I know x plus 1 is a factor, or you can use synthetic division. So I went ahead and I worked this out using long division over here. And so what I got is a quotient of x squared plus x plus 1. And so that tells me I can factor this numerator as x plus 1 times x squared plus x plus 1. Now I also know, because when I evaluate the denominator at -1, I get 0, that x plus 1 is also a factor of the denominator. So I can do the same thing. I can do long division or synthetic division, and I'll let you work that out. You can get that the denominator factors as x plus 1 times x squared minus x minus 2. And now those common factors of x plus 1 cancel. And so it's no longer an indeterminate form of type 0 over 0. And now when I plug in -1 on the numerator, I get, let's see, so I get 1 minus 1 plus 1, so I get 1. So now I get type 1 over, and when I plug in -1 on the denominator, I get 0. So I'm expecting this to tend to plus or minus infinity, just as we discussed in class. I just need to figure out the sign. But to do that, I think I want to factor a little more if I can. And I can factor the denominator a little bit further. This goes to -1 from the right. On the numerator, I have x squared plus x plus 1. On the denominator, that will factor as x plus 1 times x minus 2. And that numerator, x squared plus x plus 1, is irreducible. It doesn't factor. If you don't believe me, check the discriminant. The discriminant would be b squared minus 4ac, which is 1, minus 4, which is minus 3, which is less than 0. So I know this is irreducible. So with that in mind, let's think about the sign diagram. If we were to do a sign diagram for this, we would want to determine the roots. There are none, right? Because that numerator doesn't factor. It is undefined at -1 and 2. So if I go ahead and draw those on the real number line, I get -1 over here, and I get 2. And I want to think about what interval I'm considering for the sign. Well, I'm coming into -1 from the right, so that's the interval I want to consider. And so if I'm taking a test point, I've got to think about it on this interval, not this interval or this interval, because it can certainly change sign on either side of those vertical asymptotes. So let's go ahead and determine that sign. So the numerator is always the same sign. It's always positive because it's irreducible. It doesn't cross the x-axis. So I get a positive over, And here, let's say 0 is my test point. That gives me 1 times minus 2, which would be negative. So I have a positive over a positive times a negative. So overall, I get a negative sign, which tells me that this limit is minus infinity.